Good day, students. This is topic 1 of lesson 7, rotations. So our learning targets today will be how to represent a rotation in a coordinate plane and describe a rotation as a function within the coordinate plane and what that function rule looks like, and then also to define a rotation in terms of congruent angles and line segments. So the question that we should be asking ourselves today is, how does rotating around an axis compare to rotating around the origin? Specifically today, we're going to be looking at rotating around the origin, but there's a couple things that we do need to know that determines the difference between these two types of rotation. First, the rotation will be closer or further away from the origin. Second, we cannot use the general rules for rotating a figure about 90 degrees, 180 degrees, or 270 degrees. And then lastly, vertical and horizontal changes are calculated using the center point instead of the origin. So we're going to be looking at how we rotate about these general rules and how we rotate about the origin. Okay, so let's look at example 1. It says to rotate the figure with the given vertices across the given line using the rules for rotation. So they've given us our pre-image here, KLM, and they provided the coordinate points for that. And they've also told us to rotate it 180 degrees, and that's stated here. Okay, so if we look at our little cheat sheet here at the bottom, rotating a figure 180 degrees tells me for my x and y terms that I need to take the opposite sign for my x and the opposite sign for my y. So that means our rule says opposite x and opposite y. So let's look at all three of our points. We have k. K is 2, -1, and if I wanted to find k prime opposite of x, opposite of y would be -2, 1. And I have point L. L is 4, -1. So L prime would be -4, +1. And then M we have as 1, -4. So M prime would be -1, +4. So now that I have all my points, we can go ahead and graph our image. K prime puts me at -2, 1, which is here. L prime is -4, 1, which is here. That's L prime. And then M prime is -1, 4, which is here. M prime. So now that I have all of my points, I can go ahead and connect my vertices, giving me my image, which is K prime, L prime, M prime. So now that I've graphed my figure, let's take a look at this question that we have down here. What do you notice about the slopes of the points of the pre-image and image from the origin? So if I look at the slope from the origin, and here we have the origin of 0, 0. If I look at the slope from the origin to my pre-image points and from the origin to my image points, what will I find? Well, let's look at K, point K. So if I look at the slope of K, remember slope is rise over run. So from the origin, I'm not rising, I'm actually falling 1. So that's falling -1, and then I'm running to the right 2. So I have my slope as -1/2. And then let's look at the slope of K prime. So K prime from my origin, I'm rising 1, so rising 1. And then I'm running to the left 2, so that's actually -2. So my slope is -1/2. If I notice the slope of my pre-image K is equal to or the same as my slope for my image K. Well, is that true for all of the points? Well, let's see. We went from K to K prime, so we went to K and then to K prime. So now let's try from the origin to L. L, we went down 1, and then over 1, 2, 3, 4. So that slope right here for L would be negative 1/4. And then for L prime, we went up 1 and then 1, 2, 3, 4. So the slope here for L prime would be also negative 1, 4. So that means that the slope is going to be equal from the pre-image to the image points in any rotation that is 180 degrees counterclockwise. So that leads us to say that all rotations of 180 degrees have equal slopes from the pre-image to the image. And that makes sense because if I'm looking at 180 degrees, remember back from lesson 1, anything that is 180 degrees means that it is a straight angle. And how do we define rotations? We define rotations by angles. Okay, so if I look at from K to the origin, and then from K prime to the origin, ladies and gentlemen, I create a straight angle. And that straight angle measure is 180 degrees. So I actually have an angle here that's created. And as you can see, I've rotated this figure 180 degrees along this straight line. Okay, example 2 says, given the pre-image and image, find the rotation rule for the transformation below, given the point of rotation at the origin. Okay, so they gave us the pre-image, which is quadrilateral A, B, C, D, and they have also given us the image, which is quadrilateral A prime, B prime, C prime, D prime. And they're wanting us to find the rule based on the rotation from here, the origin. So the first thing that we can do is identify the pre-image points, which were already given to us. So A we have as 0, 2, B we have as 1, 4, C we have as 4, 2, and D we have as 3, 1. Now we can go ahead and determine what our image points are just by looking at the figure in the problem. So A prime I have as 2, 0. B prime shows me at 4, -1. C prime shows me to be at 2, -4. And then finally D prime is at 1, -3. So to determine the rule, we have to first look at the pattern that we're seeing from our pre-image points to our image points. So if I notice, I see from A to A prime, the points have switched. My X and Y coordinates have switched. So I can see that same pattern from B to B prime. I see that I have a 1, 4, now I have a 4, -1. I'm seeing some number switching. So we can start off by saying that there's some switch taking place. Now the second observation that we can see is that my X coordinates, when switched to become my Y coordinates, have also switched signs. So I see that for B to B prime, I can see that from C to C prime, and from D to D prime. So if they've switched, that means that now my Y coordinates, oh, I made a mistake here. I didn't switch them. It was supposed to be Y, X. So Y, X here. And then I see my X has now changed sign. So if I look at my cheat sheet here at the bottom, I notice that anytime that I switch and have my X to be negative, that tells me that I have a rotation of 270 degrees. So that means that I've taken my pre-image and rotated it around 270 degrees. 270 degrees, and this is counterclockwise. Now, so my answer would be a rotation of 270 degrees counterclockwise. Now let's look at our question again. What do you notice about the slopes of the points of the pre-image and image from the origin? So once again, if I look from the origin and I take one point from my pre-image and then look at the corresponding point in my image, let's see what happens with the slope. So let's first look at the slope of point B. Let's look at slope of point B. So from the origin, remember slope is rise over run. So I'm rising 1, 2, 3, 4. So I have 4 over, and then I'm running to the right 2 or 1. I'm running 1, so my slope is 4. And then let's look at B prime to see if we get the same or something different. So from the origin, I am falling actually -1, and then I am running 4. So my slope is -1/4. Well, what do I notice? I notice that here my slope is positive, and then here my slope is negative. Okay, so I have a 4 and I have a -4. So these two obviously -4. So these two obviously are not equal to each other. But if I have slopes that have the opposite signs and then 4 and 1/4 are reciprocals of each other, I can say that the slope of my B pre-image B is perpendicular to the slope of my pre-image or my image, which is B prime. So the slope of my pre-image is perpendicular to the slope of my image. So what does that actually mean? Well, if I think about perpendicular lines, remember perpendicular lines make 90-degree angles. But you're saying, well, this is 270. How do I get 90 degrees from 270? Well, let's think about this. What makes up 270? Well, we're in quadrant 1, right? If we're in quadrant 1, we start from 0. But if I rotate this figure to quadrant 2, how many degrees of a rotation does that already do? Well, in quadrant 2, that takes me to 90 degrees. Now, when I get to quadrant 3 here, quadrant 3 takes me to 180 degrees. Remember, we have 4 quadrants, and a full entire rotation would be 360. So if I get here now to quadrant 4, well, ladies and gentlemen, add 90 and we have 270 degrees. So it makes sense that this is true because we have three 90-degree rotations that we've made. So it only makes sense that our slopes are perpendicular if we're going from our pre-image to our image and looking at the slopes from our point B to B prime. Okay, example 3 says, consider the quadrilateral PQRS on the coordinate plane below. After a rotation of PQRS 90 degrees clockwise about the origin, what will be the coordinates of point R prime? So, a couple things that were mentioned here in this problem that's a little bit different than what we've did in the first two is that a rotation of 90 degrees clockwise. So if it's not already stated, we automatically assume that we're going in the clockwise position. If you notice, that's here at the bottom in our little cheat sheet. We always go in the clockwise position. But here in our problem, it's telling us to go clockwise. So if it's not stated, we assume counterclockwise, but here it's stated clockwise. In what direction do we move clockwise? Well, clockwise, we always move to the right. We always move to the right. So we're moving in this direction now. So we want to look at point R prime. They gave us R. So R we see to be 6, 4. So positive 6, 4. If I'm moving 90 degrees to the right counterclockwise, well, once again, let's look at our quadrants. Quadrant 1, okay, that's our pre-image. If I move to quadrant 2, because remember, we always move in a counterclockwise position, quadrant 2 would be 90 degrees counterclockwise, right? But then if we move to quadrant 3, that would be 180 degrees counterclockwise. Remember, I'm trying to get to quadrant 4. So quadrant 4, remember from example 2, that was 270 degrees counterclockwise. But if you notice, 90 degrees clockwise is the same. So 90 degrees clockwise is the same as 270 degrees counterclockwise. So therefore, ladies and gentlemen, we can use the same rule that we have for 270 degrees counterclockwise, which is this rule down here. And that rule tells us that we switch and we take the opposite of the x. So if I am only looking at point R prime tells me I switch them, so I have 4, 6, but I take my x and I make the opposite sign. So that means 4, negative 6 would be down here in this area. And that would be my R prime. Now let's also look at the slope to see what we notice about the pre-image and image and the slope from the origin. So here's the origin, and let's look at R. So remember the slope of R, remember that's rise over run. So we're rising 1, 2, 3, 4. So we're rising 4. And then we're moving over 1, 2, 3, 4, 5, 6. So if I reduce that, my slope is 2/3. And if I look at the slope of R prime, I'm falling 1, 2, 3, 4, 5, 6. So I'm falling 6. And I'm running 1, 2, 3, 4. So that means my slope here is negative 3/2. Once again, 2/3 is not equal to negative 3/2. However, I do notice that 2/3 is the reciprocal of 3/2, and positive 2/3 is opposite to negative 3/2. So remember, if I have the opposite reciprocals, that means these slopes are perpendicular. So that means here and this connection here are creating right angles. And that makes sense because if I'm moving 90 degrees, if I'm moving 90 degrees clockwise, that means I'm creating some type of perpendicular relationship when I'm rotating my pre-image point of R to my image point of R prime. All right, let's look at our next example. We have example 4 where it says PQ has endpoints P, which is -2, -1, and Q, 6, -5. Consider the transformation where I take my pre-image points and switch them so they can be y, -x for PQ. Part A says, is this a rigid transformation? And explain how you know. So let's first look at the rule. The rule says I switch my points and take the opposite of x. So if I look down here, I see this rule already stated for 270 degree rotation counterclockwise. So already I know that it is a rigid transformation. So is this a rigid transformation? Well, yes. How do I know? Because the rule states to rotate 270 degrees counterclockwise. Also, we know that all rotations preserve their shape and size after a transformation. Okay, so rigid transformation, once again, remember, means that after a transformation is performed, the shape and size is still preserved. And then, of course, it has to be rigid because rotation is a part of the rigid transformation family. Now, what are the coordinates of segment P prime, Q prime under this transformation rule? Well, first, let's look at our pre-image points. We have -2, -1, and Q we have as 6, -5. So if I want to find P prime, remember our rule says to switch them. So I have a -1 where my y should be, but then it also says take the opposite of the x of where it originally was. So I have -2, so that's going to be a +2. And let's do that for Q. Q we have 6, -5. So I'm going to switch them. So -5 is going to be at the front, and then 6, which was my original x, is now going to be -6. So there you go. P prime is -1, 2, and Q prime is -5, 6. All right, let's look at our last example, example 5. Sammy rotated AMEN 270 degrees counterclockwise about the origin to generate A prime, M prime, E prime, N prime with vertices at the given points. What is the sum of all y coordinates of AMEN? So first, let's look at what was given. It says 270 degrees counterclockwise. So if I come here down to my little cheat sheet, 270 degrees counterclockwise tells me I switch and take the opposite sign of x. So that is my rule. I switch and take the opposite sign of x. And they want to know what would be the sum of all the y coordinates of the pre-image. So remember, this right here is our pre-image. So our image points we have as A prime, 1, 5. We have M prime, which is 1, 0. E prime, which is -1, -1. And then N prime, which is -3, 2. And they want us to find the pre-image points, the points that came before this. So A, M, E, and N. So essentially, ladies and gentlemen, we are working backwards to figure out what the pre-image points were. So if I originally were working with my coordinates of y, -x, that means I just have to flip them back and then take the opposite of what the original x would be. So here I'm going to have 5, 1. I'm flipping it back, and then my x originally was negative here, and then I have m prime, which was 1, 0. So if I switch that back, that's just going to be 0, 1, and I can't take an opposite sign of 0. It just is what it is, 0. And then for E, if I switch them back, I'm going to have a -1 for Y, but a +1 for X. And then for N prime, I'm going to switch them back, so I have a -3 here for Y, but a -2 for X. So, but it says take the sum of all the Y coordinates. So that means I'm looking at all of these coordinates here. 1, 1, -1, and -3. So the sum just simply means to add them all up. So 1 plus 1 plus -1 plus -3. So 1 plus 1 gives me 2. 2 minus 1 gives me 1. 1 minus -3 gives me a -2. So the sum of all the y coordinates for AMEN would be -2. All right, ladies and gentlemen, this concludes lesson 7. Please make sure that you're going back to your OneNote class notebook in Microsoft Teams to finish up your lesson 7 vocabulary through the warm-up activity. Make sure you're watching the videos and brushing up on your terms. I'll see you soon, guys. Have a wonderful day.